Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Welcome back to another problem of the day discussion as well. So today we'll be discussing the yesterday's problem of the day, that is palindromic subsequence, which I gave as a bonus problem yesterday without knowing that this will be the problem that we'll discuss today. So hi Rishit and hi Naikaj and hi Krishna. Hi everyone. So guys, you can hit the like button and give me a +1 if everything is working fine, and then I will share my screen to discuss the problem further. Okay, so let me quickly share my screen now. All right, I hope that the screen is clearly visible. You can hit the like button and give me a +1 if everything is fine. Okay, now let's open the GFG POD for yesterday, and this is the POD. All right, so let me remove the code from here as well. Okay, so basically this is the problem. Let's first of all read the problem here. What does the problem say? So the problem name is longest palindromic subsequence. Okay, so in this particular problem, what we will be given is, we will be given a particular string, and in the given string we have to find the longest palindromic subsequence. Okay, so suppose we have this particular string. Let me just copy this string first of all. Okay, and let's try and run it on the board. Just give me a second, guys. Okay, so yeah, if you will see here, so we have to find what? We have to find the longest palindromic, okay, palindromic subsequence, right? Now here, what we have to do is, suppose we have been given a string. So suppose we have been given the string, and the string is s is equal to, let's say, b, then you have a, then you have b, then you have c, then you have b, then you have c, a, b. Okay, so in this particular case now, if you will observe, so what I can do is, for this b I can balance it with this b. Okay, so let's say b can be there. Then after that, what can we do? If you will observe, so I think that we can take, let's say, this a, and we can take this a. Okay, so let's say I can take a. After that, I think we can take this b and this b, so we can take bb, and then in between we can have one c individually. So if you will see here, I think the longest palindromic subsequence will be bab cbab. Okay, so basically length 7. Answers can be multiple, but the length is 7 here that I can observe. You can see here the length is 7. Okay, so basically we have to return hi mau as well. So basically mau, we are finding the longest palindromic subsequence. We are given a string and we are finding the longest palindromic subsequence here. So basically we can like in this string we have to choose some characters from here and there, and whatever characters we are choosing as a subsequence, that has to be the that needs to have the longest length such that it is palindromic also. So you can see here, if I'll choose this guy, then I'll choose this guy. Okay, this guy from the back. Okay, so this b and then this b. Then after that, if I choose this a and then this a, so I put this a here and this a here. And after that, I choose the b and this b. Okay, I choose this b and this b, and I then in between obviously I have a c. So you can see that if I choose b c, then after, sorry, b a b, sorry, if you can see here, guys, what I am choosing as a subsequence here. You can clearly see that if I choose this thing, if I choose b, then I choose what? Then I choose a, then I choose b, then I choose c, then I choose b. Okay, then I choose what? A, and then I choose b. So that is how I'll choose this whole string. Okay, basically b a b c b, and then a b. Okay, so this will be the length will be 7. So in this case we'll get the longest palindromic subsequence here, right? So that is what we have to get here. We only have one string. So if we have to get the longest palindromic subsequence, so how can we do this? Basically, we all know that we have one of the things in strings. Let's say we are given two different strings. So how do we find the longest common subsequence in that? We can use the LCS concept, because using the LCS concept we can find what? We can find the longest common subsequence. Okay, now in this case we have to find the longest palindromic. So here what we can do is, like, palindromic is what? Like when we are considering that backside is also the same. So basically what we can do here is, like, since we don't have a second string, so here since we have to find the longest palindromic subsequence in this string only, so what we can do is we can declare the string 2, which will be nothing but the reverse of the string 1 only. Okay, let's say we have originally string 1, so we will declare a string 2 which will be the reverse of the original string given, and whatever will be the longest common subsequence in the string and its reverse, that will be said as the longest palindromic subsequence. Is this part clear to everyone? Because yesterday also I had discussed the property of LCS. Is it clear or not, guys? Please tell me. If yes, then you can hit the like button as well, guys. Okay, so basically here you can understand, you have only one string given to you and you have to find the length of the longest palindromic subsequence in that. So basically you have to do what, you should reverse the string. Okay, in another string s2 you should store the reverse of the first string, and then whatever is the longest common subsequence in the string and its reverse, that can be said as the longest palindromic subsequence. Now is clear? What about others? So basically if I have to show you now, so let me just reverse this string. So let me write b a c. Okay, then b, then c, then b, then a, then b, and then b. Okay, so suppose if I have, if you will see, so I have I and j. So I can take this and this. Okay, then let's say I will take this and this. So ba I have taken, this part is common. Then after that let's say I'll take b. Okay, then after that I'll take this guy c, then I'll take this guy b. Okay, then after that let's say I'll take this guy a. Okay, a is same and then b is same. So this whole part, because whatever is the LCS in the string and its reverse, that is ultimately the LPS, longest palindromic subsequence. So we can return the length as 7 here. You can see BAB, CBAB is the CBAB is the answer. So basically the length is 7 here, length is 7, and that is the final answer that we have to return. So is this part clear, guys? You can tell me. Okay, so basically LCS concept is applied on this particular problem itself, only on the string and its reverse. So what we can do first of all is that we can first of all declare another string, let's say s2, and let's name this original string as s1. Okay, and let's have a string s2 also. Now in this string s2, what we need to do is we need to reverse. First of all, let me put s1 here, and then what I can do is I can reverse the string. So s2 dot begin, okay, comma s2 dot end. So then we can reverse this particular string, and then what we can do is we have to find the longest palindromic subsequence. So we can say that int answer is equal to LCS of what? LCS of the original string and its reverse. Whatever this is going to be, that will be the final answer. So I'll initially pass the indexes as 0 comma 0 here, right? And whenever we reach the end of the string, that will be the case when we'll return 0. So let me just do it, since we have to try out all possible ways. So here we are going to use what? Recursion, guys. So what we will do is we'll declare string ampersand s1. Okay, then we'll have a string ampersand s2, and then what we'll have is we'll have int I, that is the index I am at in the first string and then in the second string. So what we'll do, when will the condition of return be taken? Whenever any of the strings get exhausted, because I is pointing, suppose, to the first string and j is pointing to the second string. So suppose that I is at the end, I reaches the end of the string and j is still standing somewhere in between. So in that case I cannot get anything further in common. So that is why what I will do is let's write this as recursive code only. Okay, yeah. So if suppose that I is equal to s1 dot size, so if the I index get exhausted, or suppose that in another case, what can happen is, suppose I is somewhere in between and j reaches the end of the second string, so then also we will not have anything in common further. So that is why you can say that or it happens that or it happens that let me use the or operator, sorry. Yeah, or it happens that the j is equal to s2 dot size, right? So in this particular case, what we will do is we'll simply return 0 from here, because we'll not get anything further in common. Otherwise what we will do is we can say that if it happens, right, that the in the string 1 s1, the ith character is the same as the jth character of the string 2, then we can say that yes, we have one more thing in common. So we can return what? 1 plus recursion of, we can call it for I plus 1 comma j plus 1, because both of the indexes will move by 1, and we'll pass the string 1 and the string 2 here. Okay, this is what we will do. Otherwise if that is not the case, so in the else case, what we are going to do, we have two choices: either you move your I or you move your j. So in that case, we can say that choice 1 is what? That we can call the recursion, and where we can move the I index by 1, and we can keep the j as the same. Okay, and we can pass the string s1 and s2 here. So we can pass s1 comma s2 here. Okay. Otherwise, what we otherwise, what is the second choice? So the second choice is that we can keep I as the same and move our j. So we can have s1 comma s2 comma I comma j plus 1, and then we put a colon. Now we can do what? We can return the max of c1 comma c2. Okay, is this part clear to everybody till now? Please tell me, guys. Okay, so otherwise, if you have two choices, either you can increase the I and keep the j as the same, or keep the I as the same and increase the j. So this is what you can do. No, if you're clear till this point, let me know in the chat, guys. Okay, I think Rishit is clear. All right. Okay, so now after this is done, right? So suppose that this much code is done. So what will happen here? If you will see, if I'll try to run this code now, so what is going to happen? Obviously, you are going to get a TLE here. Let me just see. Okay, first, I think I'm not doing something correctly here. Okay, I'm passing. Your output is this. Okay, why is my output so big? If any of them reaches the end, then I'm returning this thing. Otherwise, if the S1 and S2 are same, then I'm doing this thing. So am I making any mistake because of which I'm not getting the correct answer? S2 I'm reversing from the starting and the back. Uh, is there any mistake in my code? Basic code here. Let's try and run it again and see what error we are getting here. I'm getting random answers. Okay. Max of C1 comma C2. So if any one of them reaches the end, then I'm returning 0. This is also fine. Did I miss something here? Okay. So I have the string. Okay, yeah. So should I have passed the size? I don't think so. So I'm reversing it from the beginning till the end. Am I making some mistake here? First of all, I declare a string s2 and in that I pass s1. Okay, then I'm reversing it. Okay, then I'm passing s1 and s2. Okay, yeah, I'm not returning the answer. No, sorry, guys. I'm not returning this answer. Very sorry. Yeah, I was not returning the answer. I was just calculating it. That is why the random value was shown there. So basically, I was not returning here. Okay. So yeah, now when I return the answer, so it works fine. Now when I'll submit this code, then it will give us a TLE. Why it will give us a TLE? You will understand that once we get a TLE. Okay. So yeah, you can see clearly that we are getting a time limit exceeded error. Now why? Because what happens here is, if you will observe now, so if something is already calculated, why do you want to calculate it again? Because if you see, the function is like this. If you have f of ij, so one time what is happening is you have I plus 1 comma j. Okay, another time what you have is f of I comma j plus 1 as always. So since you are having this thing now, guys, so if you will write the diagram for it, so suppose you are starting from 0 comma 0. So one time what you do is you do f of 1 comma 0. Another time it will be like f of 0 comma 1. Here it will be what? F of 2 comma 0, and here it will be f of 1 comma 1. Here it will be what? F of 1 comma 1, and here it will be f of 0 comma 2. Then if you move it further, so f of 3 comma 0, this will be what? F of 2 comma 1. Then this will be what? F of 2 comma 1, and this will be f of 1 comma 2. Now this will be f of 2 comma 1. This will be f of 1 comma 2. Now this will be what? F of 1 comma 2, and this will be f of 2 comma 1. So you can see, if something is already calculated, if f of 1 1 is already calculated, then why do you want to calculate it again? No, that is the thing. Yeah, or that. Yeah, we forgot to return. Now it was working fine. So yeah, basically you can see that if something is already calculated, why do you want to calculate it again? Because total number of different ij pairs will be what? Total number of distinct I comma j pairs will be nothing but n square here, right? Now if you are calling, like, you can see the number of calls is what? Here you have one call, two call, four calls, so it is increasing exponentially. So the total number of calls that you are doing is 2 to the power n square, right? If you are calculating the same values of ij again and again, you can see this ij pair is calculated again. Then if I highlight it with another color, then you can see that if 2 comma 1 is already calculated, do you want to calculate it again here? Do you want to calculate it here again? No. If suppose that 1 comma 2 is already calculated, do you want to calculate it again? No. So we want to calculate each and every different pair of I and j exactly once. So that is why if we calculate each and every pair exactly once, so we have to use dp for this. So the time complexity would reduce to order of n square. Is that clear? Because each will be calculated exactly once. So that is how we can use the dp approach, dp thing here. So basically we have to just declare a 2d dp, which will be n square size. So let me just declare it. Okay, vector of vector int. Okay, and let's name this as dp, and initially n comma, then I can declare it as vector int n comma minus 1. So initially I've declared a n cross n dp, which is having the all the values initially as minus 1. That is not calculated. I'm passing this dp. So let me pass this dp here also in the functions. Okay, in this call also I'm passing it. Fine. Now after that, I'll pass it here also. So let me pass it vector of vector int. Okay, ampersand dp. So yeah, basically I'm passing this dp here, and if a particular state is already calculated, if dp of ij, okay, if it is not equal to minus 1, so if something is already calculated, then why to calculate it again and again? So if it is not equal to minus 1, so this means it's already calculated. If it is calculated, then directly return its value. Okay, otherwise if it is not calculated, then what you do is you calculate the value, store it, okay, and then like store it inside the dp, and then return it, so that next time you don't have to calculate it again and again. Okay, then you return dp of ij here. Similarly here also, if something is already like if it is not calculated, calculate it, store it, okay, and let's name it as mx in fact. Okay, calculate it, store it, and then what you do is store it, so ij is equal to mx, and then return it, so that next time you don't have to calculate it again and again. Okay, so since you have stored, now let's try and run this code on the sample. Is this much part clear also, guys? So yes, you can see here. Okay, I'm not declaring the dp properly. Okay, n was not declared, so I need to take the size of the string int n is equal to s1 dot size. All right, now it should work fine. Let's see. Now it's working fine, guys. Let's try and submit this code and see if it gets accepted or not. And I think it will get accepted, guys. Yes, it does get accepted. So is this problem clear to everybody, guys, how we are doing it? Basically, idea is the same. You are doing what? In order to find the longest palindromic subsequence in the string, in single string, you have to do what? You have to find the longest common subsequence in the string and its reverse. So you are just using the LCS concept here. And since you want to calculate each and every state exactly once, because if something is already calculated, we don't want to calculate it again and again. So that is why instead of 2 to the power n square, the complexity would reduce to order of n square, because we'll calculate each and every I comma j pair exactly once. So that is why the time complexity ultimately for our code will be nothing but order of n square at the end, because we are calculating each state exactly once. Talking about the space complexity, so since we are using extra dp array, 2d array, so the space complexity in this code will be order of n square, and the recursive space will also be included here, right? But overall it will be n square only. So is this clear to everyone? And this problem has been asked in Amazon and Google. So this is a really good problem that has been asked in Amazon earlier and Google also. And this is nothing but a LCS derivative problem, as I had told yesterday also. So let me just provide the code, and you can hit the like button if you're clear till this point, and let me know if there is any doubt till this point. Any doubt till this point, guys, or things are clear? So what I will do is I'll just generate this thing. Okay. All right, the code gets generated. Now let me paste it in the chat. Okay, yeah. So this problem was basically asked in Google, Amazon, and maybe a lot of companies have asked it as well. So you can see here expected order was also n square n square. So we have done it in the expected things. Okay, thanks a lot. Balaji is also clear with this problem. Very good. Let's have a look what will be the problem of the day for today. Okay, so let's see what is the problem of the day for today. I hope the screen is visible. So non-repeating character. So we will see this problem. I think it's quite easy and has been asked in a lot of companies. So try to solve this problem, and tomorrow we will see what the problem actually says. And I think it will be a easier problem for us. So that is it for today, guys. If there's anything that you want to ask or say, you can tell me. Otherwise, make sure to hit the like button if everything is clear, and you can give me a +1 as always. If there's any, if this video was helpful for you, so please comment understood in the chat. And thanks a lot for joining. Thanks a lot, Balaji. You have already solved it. Yes, I think it was an easy problem. Thanks a lot, Mau, for joining. And I think for Mau it was an easy problem because she already has done a lot of problems. Maybe better she has done a better DP problems compared to this one, even. Okay. So yeah, thanks a lot, Rishit. Thank you, Mau. And Balaji, I think, has already solved today's problem. Very good. Thanks a lot, Mau, as well. And thank you, Balaji. So thanks a lot, guys. I'll see you with the problem of the day tomorrow. And till then, keep coding, guys. Be consistent. Keep solving. Keep upskilling yourself. And thank you, everyone. Happy coding.